Okay, let's look at the practice exam 3, problem number 6, right? So we want to find an equation of the function, original function, which passes through the point 4, 5. So this actually gives us a clue. So this basically said that if you plug in x equals 4, function value must be 5, right? Then we have a derivative here. So we're going to take the antiderivative to find the original function. Right, before we do that, we need to simplify this derivative using a long division. Right, so let's do that. So you have x squared minus 4x plus 5, and we are dividing that by, right, denominator is x minus 3. Right? Then pay attention to the leading term. Leading term is x squared. Then we have to think about how many x's can we squeeze into x squared. So it'll be x, right? So x times x is x squared. X times negative 3 is negative 3x. Then we subtract, right? X squared minus x squared is 0. Negative 4x minus negative 3x. So you're adding 3x to negative 4x. So that would be negative x. And then you have a plus 5. So you bring plus 5 down here. Right? Then we think about how many x's can we squeeze into negative x. So that would be negative 1. Right? So negative 1 times x is negative x, which is what we wanted. Negative 1 times negative 3 is positive 3, right? Then go through a subtraction. Negative x minus negative x is 0. 5 minus 3 is 2, right? Which means that we can rewrite f prime of x this way, right? First, you put the quotient, which is x minus 1. So you have x minus 1, right? Then you have plus, right? The remainder is 2. So put 2 on top, right? And you have a divisor is x minus 3. So put the x minus 3 on the bottom, right? This is exactly the same function as the original function here, right? So in order to find the original function, we take the antiderivative. So you have f of x is equal to antiderivative of x minus 1 plus 2 times 1 over x minus 3. So 2 over x minus 3 dx. Right? The antiderivative of x is add 1 to the power, so x squared over 2. And the antiderivative of negative 1 is negative x, right? Then you have 2 is just a constant. I'll put it in front. Right? Antiderivative 1 over x minus 3 would be, right? Remember that if you have g prime over g, then if you're taking the antiderivative of this guy is always natural log of absolute value of the denominator, right? Plus c, right? So if you're looking at integral of 1 over x minus 3 dx, right? So you can see that this is g of x, and derivative of x minus 3 is 1. So this is going to be just the natural log of absolute value of x minus 3 plus c. So antiderivative of that would be natural log of absolute value of denominator x minus 3, and then you have a plus some constant c, right? So this is the best we can do from the derivative, but we have another clue. It says that when you plug in x equals 4, we should get 5. So let's plug in x equals 4. So f of 4 is equal to, right, 4 squared is 16. My over 2 would be 8. Minus x is 4. Plus 2 times natural log of 4 minus 3 is 1. Plus c. Right? But the natural log of 1 is 0. So this can be simplified as 8 minus 4 plus 0. So it's going to be 4 plus c. And it's supposed to be 5. So set that equal to 5. Right? Then we can just subtract 4 from both sides of the equation so that we can find c. c is positive 1. All right, so therefore we have a complete formula for f of x. So f of x is equal to, right, x squared over 2, right, minus x plus 2 natural log of absolute value of x minus 3 and plus some constant c, so plus 1, right? So this is f of x that we are looking for. All right, that's it. I hope that this was clear.